In today's video we're going to be taking a look at how depths and heights are defined on a nautical chart, talking about chart datum, the height datum, and how you work between them. As with most of what I create, check out the description for a link to my website where you can find a load of information and diagrams to just help you understand the topic in a little more depth. So, firstly, where do you find chart datum and what is it? Well, as the name implies, chart datum is found on a nautical chart. If you take a look in the top left corner normally, where all the description and all the text is, you can see a reference to the soundings. On this particular chart, soundings are in feet, at mean, lower, low water. That means the chart datum for this chart is mean, lower, low water. You'll find loads of other ones in use, like lower low water on large tide, lowest astronomical tide, Admiralty chart datum, mean sea level even if there's not much tide in an area. All it does is it provides a consistent reference point from which all soundings on this particular chart are measured. If we take a look at this diagram, we can start to see how it works. I can add on chart datum just as an arbitrary line across. We've already said that it doesn't matter where it is as long as it's consistent across the chart. Charted depths are measured from chart datum down to the seabed, but occasionally the seabed also goes above datum. When this happens, you'll be given a drying height instead. As the name implies, a drying height indicates an area that might well dry out at certain states of tide. Let's add in the tide to see it oscillating up and down. So at high water, obviously everything is covered by the tide, but once we get down to some of these low waters, this drying height starts to have an effect and we start to see a little bit of rock poking up above the water. Now that we've got the tide on and moving, it seems like a good time to talk about the tidal definitions. The first line across here is the point at which the tide is oscillating around. It spends an equal amount of time above it as it does below, and we just call this the mean sea level. Next, we've just got the different high and low waters, and we split them up into springs and neaps. When the tides are neaps, you're going to get those lowest high waters, and if we average out all the neap high waters, we can find this line here, which is the mean high water neaps. Similarly, at the low waters, we'll get the mean low water neaps. As the tidal cycle continues, we're going to get to the springs, and we're going to get similar lines, so we'll get the mean high water spring, which is the average of all the spring high waters, and its corresponding mean low water springs. Of course, being means, they're just averages, so occasionally you're going to get bigger spring high waters or lower spring low waters. The ones caused by astronomical effects alone are going to give us our highest astronomical tide and our lowest astronomical tide. These ignore the effects of, say, a big high pressure or a big low pressure area or storm surges and things. These are purely the ones that are caused by astronomical effects, so they would be forecast on your tide tables. For completeness, I'm just going to add on a couple of ranges at the side, so between the mean high water neaps and the mean low water neaps we're going to get the neap tidal range, and similar for the spring tidal range, so you can see the different range that you're going to get with the tides. Now that we've got the tidal lines on our diagram, we can look back at the chart datum and notice it lines up with the lowest astronomical tide. I've done that on purpose. Lowest astronomical tide is one of the most common datums you're going to find on a chart in tidal areas, because it just corresponds with the lowest level you can expect the water to ever get to. As I say though, it really doesn't matter what datum is in use as long as it's consistent across the chart and your chart and your tide table are using the same datum. That's really important because when we're trying to work out how much water there actually is, this distance here, the observed depth, we're going to need to add together the charted depth and the height of tide. That height of tide is going to come from your tidal calculations, so it's vital that those calculations come from the same chart datum that your chart is using. Of course, for drying heights it's similar, you just have the height of tide and you minus the drying height to get the distance from the seafloor there to the waterline. Once you know the actual depth of water, you then apply it to your own vessel, working out how much water you've got below your keel. You want the depth below keel, and that's simply the observed depth of water minus the draft of your ship. If it's a positive number, it means you've got water underneath you, so you're not going to run aground, just safe to go there. But this is only half the story. What if I add on a lighthouse or a bridge? We're starting to build in charted heights or charted elevations, and these are numbers basically just telling us how high something is. You would think it's from chart datum, but it's actually not. If we go back to our chart, we can see heights are in feet above mean high water. It could be mean high water, it could be highest astronomical tide, it could be mean high water springs, it could be anything. What it's telling us is there's a different datum that's used for heights. On my diagram, I'm going to take mean high water springs as my height datum. So it means that the bridge has a charted height above the height datum. Similarly, the lighthouse to the focal plane of the light will have a charted elevation from the datum to the focal plane of the light. Now the difference between the datums becomes vitally important when you want to know this distance here, the distance between your vessel and the obstruction above you, whether you're going to fit underneath. You're going to have to get everything back to the original chart datum. So for the height of the bridge above chart datum, you want the charted height plus the difference between the two datums. So in my case, I need the height of mean high water springs, and I'm going to need to consult tidal information to find that out. Adding those two together will give me the total height of the bridge above chart datum. Next, I need to find out how high my mast is above chart datum. And for that, you can see I need the height of the tide plus the air draft of the ship. Adding those two together will give that height of the mast above chart datum. Taking those two numbers together, I can see if the total height of the bridge is greater than the height of my mast, and I can subtract one from the other to work out the vertical clearance. So it leads us to the question, why are the two datums different? Why do we need to go through all that to work out a vertical clearance? Well, think about it. If you're looking at a chart and you ignore the effects of tide, you want to know the depth of water at basically the lowest that the tide is ever going to be, so that any tide you have is going to increase that water depth and make it safer. So it makes sense to set your chart datum at the lowest point it should ever reach. It's similar with the heights, where the most critical situation is going to occur when the tide is really high. So we want those charted heights to be measured from quite a high point, so that whenever the tide is below that, there's actually an increased margin of safety. Although it makes it a bit of a pain for calculating everything, you only actually really need to calculate it when the numbers are getting close. If you look at your chart, you can immediately see there's loads of clearance above you and loads of depth below you. You know that by adding on the effects of tide, those numbers are actually only going to increase, as long as you've checked the datums and you know what they're referencing. And that brings us to the end of this tutorial. As I said at the beginning, check out the link in the description down below to head over to my website, where you'll find an article talking about all of this with a whole load of useful diagrams. And as always, if you have any topics you'd like me to cover, or any worked examples you'd like me to run through, let me know in the comments below, or even better, come and join the community, because then I'll be guaranteed to see it. Otherwise, until next time, thank you for watching, and goodbye.